Hello there. In this video, we're going to be talking about arithmetic sequences, and we're going to be trying to make some connections so that we can find some shortcuts and get more meaning. So these first three, they're very similar to the ones that we looked at yesterday, and you will notice that in each of these, they tell us what the first number is. So, in number 1, they say the first number is 8. They say to get the next number, because this is what this is saying, to get the next number, you take what you have now and you subtract 2. Well, in that case, I can go, my first number is 8, the next number then take away 2 is 6, next number take away 2 is 4, and so on. They want us to write the explicit equation, which, remember, is a sub n equals a sub 1, which is the first number you start with, plus d, which is how it changes, times n minus 1. So in this case, my list, I start with 8, and this is going down by 2 each time. So I'm going to subtract 2, n minus 1. And there's my explicit equation. In number 2, they tell me I'm starting with 0, but this one looks a little bit different. This is saying, to get my next number, take 5 plus what I started with. Okay, all they did was they just changed sides here, and that's okay. So, 5 plus 0 is 5, 5 plus 5 is 10, and so on. Well, to get my explicit equation then, it's first number plus how it's changing, going up by 5, then n minus 1. Over here, if you notice, we got a fraction here, and that's 1. Well, if we have a fraction, I'm going to keep working with fractions. So 1 whole as a fraction is 3/3. So 5/3 is my first number, plus 3/3 is 8/3, plus 3/3 is 11/3. So my explicit equation would be first number, 5/3, plus how it's changing. I'm adding 1, then n minus 1. Now, I suppose you could say 3/3 right here. It wouldn't be wrong, okay? But you should write all fractions in simplified form. Now, here's why this is important. If you notice, each of these, the first number is what you start with. They tell us that. It's a sub 1. We know that. What I'm looking for is a shortcut so that you don't need to make this list. So, if you notice, whatever we're doing, in this case subtracting 2, adding positive 5, adding positive 1, that's what goes in front of the n minus 1. So, essentially, this is d in the formula. Every time, that'll be d. So there's a shortcut for you. Now, in the next several problems, what we have is a list, okay, recursive equation, they want the explicit equation, and they want us to make up a context for it. That context could really be anything you want. So, to find the recursive equation, this is just saying first position, second position, third position, etc. So, I start with, first number on the list is 8. This is changing by going up 8 each time. I'm sure you remember that from Math 1A. So, get my next number, first number, plus how it's changing, 8, then parentheses, n, oh, I'm sorry, this is recursive. So it's a sub n equals a sub n minus 1 plus 8. It's okay, we all make mistakes. But now I can cheat. The explicit equation is first number plus the difference, n minus 1. It's a shortcut. Now, for the context. The context is just any situation that you want it to be. Okay? You could just make it up. So, for instance, you could say, looking to the future, and I'm one of those crazy people that, loves animals, so I start with 8 cats and get 8 more each month. There's a context. That fits. You start with 8, and it's telling you increase 8 each time. So, now you could just make the graph that goes along with this. So like 1 is 8, 2 is 16, 3 is 24, and so on. That's just a nice visual. Now, if you notice, these are just points. There's nothing in between these because it doesn't make sense to have anything in between here right now. These are what they call discrete points. Alright? So, looking down at number 3 now. So, we could say, they tell us we start with 4. It goes up by 3. So, 7, 10, 13. So, ours would be 1, 2, 3, 4. We always start with 1 and assume it's 1 unless we are told otherwise. Okay, and how you deal with that, we'll talk about in class. The explicit equation, I could look at this and say, okay, a sub 1 is 4, that's what I start with. My common difference is 3, n minus 1. So I could say my context. Say, I start with 4 Twitter followers. And add 3 per hour. There is a valid context. Good enough. Okay, so moving on. Okay, notice I didn't do the graph, just a time thing. Here they give me the explicit. So I'm going to go from here to the recursive. First, the first number I know is 4. Now, a sub n equals a sub n minus 1. This is changing by going up 5. Okay, so recursive equation is done. Now, for my table, 1, 2, 3, 4. So it starts at 4. Okay, so and add 5 each time. 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 5 is 19. Okay, and make up a context for that. Okay, let's see. I have $4. I make $5 per hour. Good enough. There's a situation. Now, number 5. Here it is in words. Jada wants to know how many seats are in each row of the theater. Jamal lets her know that each row has 2 seats more than the row in front of it. Okay? 2 seats more. The first row has 14 seats. Okay, so first row, 14 seats. Each row has 2 more than that. So that means it's going up by 2. To get the explicit equation, 14, that's what I start with, plus the difference, 2, and minus 1. Since I'm being asked to make a table, I shall. First row has 14 seats. Second row, add 2, 16. Third row, 18. Fourth row, 20. So, just describe the similarities and differences between linear equations and arithmetic sequences. We could talk about that in class.